good afternoon everyone. So today we will discuss interpolation with equal intervals. So in last two class we have seen forward difference, backward difference, central difference, and application of this finite difference. So here we will deal with interpolation with equal interval. So what is interpolation? Interpolation is the process of estimating unknown values that fall between two known values. So we have done some numerical based on this. So we have calculated the value of y when x is given. Okay, so let's suppose y is equal to f of x. Okay, so this is entry, this is known as entry, and this is arguments. Okay, so so x is argument and x is argument and y is its entry. Okay, so here what we do, we find the values of the unknown value of y which fall between any two values. Okay, so this is done with finite differences. Okay, so first we have seen forward difference. Okay, so we seen this symbol, it is forward difference operator, and it is also known as only difference operator, or it is also known as descending operator. Okay, so this is del, which is delta, which is known as forward operator. Okay, so we have seen first difference. So first difference, so we will see in terms of function. Okay, so first difference, del of f of x. Okay, so this is the difference of f of h plus h minus f of x. Okay, so where h is small step. Okay, so what is this f of x? F of x is difference of function of when you increase the value of f of x by a small step h minus the original value. Okay, so this is your first difference, and f of difference f of x plus h. So this will be incremented by 2h h. So this will be s plus 2h minus f of x. Okay, and similarly f plus 2h will be equal to f of x plus 3h minus f of x 2h. So this is first difference or first forward difference. Okay. Now second difference. So this is given by del square, delta square fx is equal to, so this can be written as like this. Okay, so it can be written as, this will be f of h minus f of x, or this can be written as f of x plus 2h minus f of x plus h. Okay, and del of this will be minus f of x plus h minus f of x. So this is your second difference. Okay. So I am audible now. Okay. So next, so del square f of x will be equal to f of 2x plus 2h minus this will become 2 f of x plus h plus f of x. This is your second difference, and similarly you can find third difference. So third difference will be del cube f of x. This will be del into del square f of x. Okay. So substitute here and again increase, find the difference. Okay. So this is your first, second, and third difference. Okay. So we are revising what we have learned previously. Okay. So next, backward difference. So it is denoted by this del. Okay. It is also known as lambda. Okay. So backward difference f of x is equal to, it will decrease the value of x by h. So this will be f of x minus f of x minus h. Okay. So in backward, we find the function and we decrease this value of x by h. So this will be equal to difference. This is backward difference, and this is known as backward difference operator. Okay. So similarly, we can find the second difference. So this will be equal to del of f of x. Okay. So difference of this will be f of x minus f of x minus h. Okay. So previously, f of x we have taken y of x minus h we have taken x minus h, and f of x plus h is equal to yx plus h. Okay. So this is same. So today we are doing it with respect to functions. Okay. Function f of x. So this is your backward difference. So we operate this function again with this backward operator. So you get del square f of x is equal to f of x minus f of x minus h minus 1 minute. Now it is audible. Okay. Okay. So del operator f of x give you f of x minus h, and we operate this on backward operator on this. So this will be f of x minus 2h. Okay. So you will get f of x minus 2 f of x minus h minus f of x minus 2h. Okay. So you can find the value of del square f of x. Okay. So this is your backward operator. Okay. Now there is another operator, identity operator. Okay. So this is denoted by I. So I f of x will give f of x. Okay. This will be same. So now I am audible. Hello. So identity operator here, I f of x is equal to f of x. Okay. Next, with shift operator is denoted by e. So e f of x will increase the value of f of x by h. So this will be equal to x plus h. Okay. And f of e square f of x will be equal to f of x plus 2h. Okay. E cube will be equal to f of x is equal to fx plus 3h. So this will increase the value of x by h. Okay. So this is shift operator E. and E inverse will decrease the value of x by 1. So this will be equal to f of x minus h. E minus 2 f of x will be equal to f minus 2x, and E minus the f of x gives you x minus 3h. Okay, so this is shift operator E. Okay, so next, central difference. Divided by length. So this is central difference operator, and f of x is equal to f of x plus h by 2 minus f of x minus h by 2. So this is your del f of x. It is central difference operator. So it will increase the value of x by h by 2 minus f of x minus h by 2. Okay, so this is your del operator. Sorry, central difference operator. Okay. So this is the formula for central difference operator. Okay. So del f of x is equal to f of x plus h by 2 minus f of x minus by 2. Okay, so this can be written as f of x plus h by 2. So we have increased the value of x by h by 2. So it can be written as e to the power half f of x. Okay, so what is e to the power half f of x? It will increase the value of x by h by 2. Similarly, f of x minus h by 2 will be equal to e to the power minus half. So it is decreased by h by 2, so it will be e minus half f of x. Okay, now substitute these values here. So del of f of x will be equal to, so this will be e to the power half f of x minus e to the power minus half f of x. Take f of x common, so this is e to the power half minus e to the power minus half f of x. This is del f of x. So this will be cancelled out. So del will be equal to e to the power minus half, so plus half minus e to the power minus half. So this is the relationship of central operator with shift operator E. Okay. Now we can write relationship between forward operator and E also. Okay. So relationship between delta and E. So what is delta f of x? Is increment of f of x minus f of x. Okay, and also we know that this f of x plus h is incremented value of f of x when h is added to x. So it is nothing. It is e f of x. So you will get e f of x. So substitute here. So del f of x is equal to e f of x minus f of x. So this will be equal to e minus 1 f of x. So forward operator, this will be cancelled out. So del e is equal to e minus 1. So this is the relationship between e and delta. Okay. And now relationship between backward operator and e. So how they are related?
So backward operator f of x is equal to f of x minus f of x minus h. Okay. So in the last class, I had written is the forward operator. So this is correct one. So this is f of x minus, this will be e to the power minus 1 f of x. Since e to the power minus f of x is equal to f of x minus h. Okay, so this is nothing, it is e inverse f of x. Okay, so now take this common, f of x common. So backward operator f of x is equal to 1 minus e inverse f of x, or this is equal to 1 minus e inverse. Okay, so this is the relationship. So forward operator is equal to e minus 1, and del is central operator is equal to, so this is the solution. So this is generally asked in the exam for 2 marks. Okay. Then we go with average operator. It is given by mu, or it is also known as mean operator. Okay. So mu is of f of x is equal to half f of x plus h by 2 plus half x of h minus. Okay, so this is average operator. Average operator f of x is equal to this formula half. So it is average or mean. So it is half f of h plus h by 2 plus half f x minus h by 2. Okay. So also we know that f of x plus h by 2 is equal to e half f of x, and f of x minus h by 2 is e to the power minus half f of x. Okay, so substitute the values of f of x plus h by 2 and f of x minus h by 2. So we will get mu is mu into f of x is equal to, so this is e to the power half f of x half e to the power half f of x plus e to the power minus half f of x. Okay, so this will be mu equal to f of x will get cancelled out. It will be half e to the power half plus e to the power minus half. In the last class I have written here minus. Okay, so correct it. So this is relationship between shift operator and average operator. Okay, so new formula mu is equal to half e to the power half plus e to the power minus half. Okay, so these are the relationship between different operators. Okay. Now, so we know that del is equal to e to the power minus half, so plus half e to the power minus half. If we take e to the power minus half common, okay, so this will become e to the power half divided by e to the power half, so this will be e minus 1. So this is del. So del is equal to e to the power minus half e minus 1. And what is e minus 1? E minus 1 is del. So this will be equal to e to the power minus half into del. So central difference operator is equal to e to the power minus half into forward difference operator. Okay. So next relation is del is equal to e to the power minus half into del. Okay. Similarly, okay, next go with D operator, differential operator. So next operator is differential operator. Okay. So D f of x is the differentiation of f of x with respect to x is equal to f dash x. Okay. Now we have taken it as y, so we have to be dash. Okay. So you have seen this earlier. D is equal to differential operator. D f of x is equal to dv by dx f of x. F dash x is equal to y dash. Okay. So from Taylor series, we have f of s plus x is equal to f of x plus h f dash x plus h square by factorial 2 f double dash x plus h cubed by factorial 2 f equal to x plus so on. Okay, so this is the case. So f of d f of x. So this is f dash x. So it is d f of x. So this is f of x plus h into d f of x. Okay, and d square f of x is f of double dash x. So this can be written as h square by factorial 2 d square f of x. And this will be h cube by factorial 3 d cube f of x and so on. Okay, so this is written in terms of d. So take f of x as common. So this will be 1 plus h into d plus h square by factorial 2 into d square plus h cube by factorial 3 into d cube plus so on, and f of x is taken out. Okay, so and what is f of x plus h? Okay, so f of x plus h is e f of x. So if we operate this shift operator on f of x, we will get f of x plus h. So this will be equal to e f of x. So f of x will get cancelled out. So e will be equal to 1 plus h d plus h square by factorial 2d square and h cube by factorial 3 d cube and so on. Okay. So what is the value of this expression? Anyone? So give the value of this summation. Okay. So this series will be equal to 1 plus hd plus h square, or it can be written as hd whole square factorial 2 plus hd factorial whole cube by 3. So this series resembles to the value of this series is given by Anyone? So this will E will be equal to this exponential series, okay, E H D. So E is equal to H into D. So E is equal to H e to the power H into D, where D is differential operator. Okay. And E is what? E is, you know that E minus 1 is equal to del, or E equal to del plus 1. So this can be written as del plus 1 is equal to E to the power HD, or del is equal to HD minus. So del is equal to E to the power HD minus 1. Okay. So this is the different operators and their relationship. Okay. So one question is there. It is generally asked in exam. It says prove that e to the power x is equal to del square by e to the power x. This is important. E to the power x by del square dx. Okay, so you have to prove that e to the power x is equal to del square by e to the power x, e to the power x del square e of x. Okay, so we will start with this term. So del square e by e to the power x, we can written as del square e to the power minus 1 e to the power x. Okay, so we can written as e to the power minus 1 e to the power x. Okay, and what we know, e to the power minus 1 f of x, so this will decrease the value of x by h, so this will be like this. Okay, so now e to the power minus, now function is e to the power x, so this can be written as e to the power x minus h. Okay, so this can be written as del square by e to the power x is equal to, so del square, and this e to the power minus x is e to the power h minus x. Okay, so now this can be written as del square e to the power x into e to the power minus h. Okay, so now we write this whole term RHS. So RHS is equal to del square e by, so this is done as del square e to the power x into e to the power minus h into e to the power x divided by del square e to the power x. Okay. So now what is this e to the power x? So e to the power x will increase the value of x with h, small step h. So RHS can be written as del square e to the power x e to the power minus h into this term will be equal to e to the power h plus x divided by del square e to the power x. So this is del square e to the power x e to the power minus h. So this can be written as into e to the power x into e to the power h whole divided by del square e to the power x. Okay, so del square will cancel out, e to the power x will cancel out. It is e to the power minus h, it is e to the power plus h. You will left with e to the power x. So this is equal to h. Okay. So this is derivation. So this is quite important numerical. Okay. So what we have studied till now. So this is your so we have studied this operators today. Okay, so this is your forward operator, forward difference operator. Okay, this is backward difference operator. It is central difference operator. It is average operator. It is identity operator. This is differential operator, and this is shift operator. Okay, so these are the operators which we have learned today. So one question will come from these operators in the exam. So del f of x is equal to f of x plus h minus f of x. That operator f of x is equal to f of x minus f of x minus h. Then central operator f of x is equal to x plus divided by 2 minus f of h minus divided by 2. Then average operator f of x is equal to r f of x plus h by 2 plus r x minus h by 2. Okay. And then d is differential operator d by dx f of x df of x f dash x, and e is shift operator f of x plus h. So these are the formulas of different operators. Okay. So there are many relationships between these all operators. Okay. So we will do one numerical. Okay. Given as x is 1, 2, 3, 4, 5, and y is 2, 5, 10, 17, and 26. So this table is given. Okay, and you have to find del square y. So you have to find the table is given, corresponding value of x is given, and corresponding value of y is given. Okay, so you have to find del square y phi. Okay, so this is your y1, this is y2, this is y3, this is y4, and this is y5. Okay, so you have to find del square y5. Okay, so what is del phi? del y phi. So it is del y x is equal to y plus x minus y over x. Okay. So this will be equal to y phi minus y4. Okay. And del of del square y phi is equal to del of del y phi. Del of y phi minus del 4. Okay. This is y of del phi minus del of y4. Y phi minus y4 minus y4 minus minus 2y4 minus. Okay. I can okay. Sorry, leave that. Leave that. This will be equal to 26 minus 2 into 17 minus 10. Okay. So there is plus 36 minus 32, 2 hours. So we are getting minus 18. We get 2. आप लोग कितना आ रहा है? चेक कर लो. So y5 is 26, y4 is 17, and y3 is 10. So you will get 2. Okay. चलिए. So this is all about forward, backward, and central differences and their relationship between and different operators. Okay. So in next class we will see languages method. Okay. Any doubt? Okay. Okay. Thank you, class.